Okay, excellent. We're off. Hey, everybody, welcome. This is our first seminar for 2025. Let me get us started by, sharing my screen and telling you what we have planned for you. So today we have Katka Borovičková from the Richmond Fed talking about a very exciting macro labor project. We're going to have two more talks in the semester. We're going to have Quentin Van Leeuwen on May 12th, switching a bit to macrofinance. And our last seminar for the semester is going to be Guido Menzio from NYU giving a talk on markups. So we have a good mix of macro finance and product market search as we should. Before heading to the actual seminar for the day, I want to flag the book interview we did a month ago with Ben Lester, Pierre-Olivier Weil, and Julian Hugonnier about their new book, The Economics of Over-the-Counter Markets. We're going to put the link in the chat so you can access the book, the video later. It's very interesting. They're talking about their new book about over-the-counter markets, and my favorite part was when they talk about the new directions that this research is gonna take. One last word. Many thanks to our amazing panelists for taking the time and offering their comments to the seminars. Your time is very much appreciated, folks. Katka, floor is yours.
Okay, thank you very much for the invitation. Thank you everyone for coming. Let me start sharing the screen again. And I think it works, right? Yeah, okay, good.
Great.
So today I'll be talking about assortative matching and wages, the role of selection, which is a joint work with Rob Scheimer. And because I'm at the Federal Reserve Bank of Richmond, the usual disclaimer applies. So in this paper, we develop and solve and analyze a random search model of the labor market, which features heterogeneous workers meeting with heterogeneous firms and creating matches. So the workers will have different productivity levels that will be denoting X. The firms will have also different productivity levels that will be denoting Y. And whenever can the firm meet in a search market, they will draw a match-specific idiosyncratic shock that will be calling Z. Whether the workers and the firm want to turn the meeting into a match will be a mutual decision that will depend on comparing the value of meeting or the value from matching, comparing to the outside option of staying unmatched, with the wage being determined by Nash bargaining. So the equilibrium object, the wage, will depend on all three important productivity levels, which is the type of the worker, productivity level of the firm, as well as this realization of the match-specific shock. We prove several interesting results in this model. We prove that this model generates wage and sorting patterns that have been documented in the administrative data. What are those? So first of all, we'll prove that the observed log wages between different workers and firm types are increasing in the worker and in the firm type. So the wages are monotone. And then we'll also show that this model features assortative sorting in equilibrium, where high type workers will be more likely to be working in high type firms. So why is this interesting? So these results are interesting exactly because they speak to the empirical evidence to the recently documented empirical evidence. So that to fix ideas and just to show what type of evidence I have in mind, let me just put this figure from Bonham, Lavadon, and Manresa 2019 Econometrica paper, where they use Swedish administrative data to estimate what the average wages look like in matches between different workers and firm types, and what are the sorting pattern between these two types of agents. So on the left side, you see a picture that shows the average log wages for a given worker type in different firm types. So on the horizontal axis are different firm type classes, with one being representing the least productive firm and 10 representing the most productive firm. Each line corresponds to one type of the worker, with the dark blue line being the least productive workers and the black line being the most productive workers. So the pattern that stands out from this is that if you fix a worker type and you ask how much this worker earns in different firms, you would conclude that this worker earns a higher wage in more productive firms. And this is that's one observation. And the second is that these wages are ordered in the sense that the best workers have the highest wages in all possible matches, while the worst workers have lowest wages in all possible wages. So this is maybe in this picture, one exception would be the really lowest types, but the standard errors are also pretty large there. So this is just to document what I mean by monotonicity. So the wages, average log wages seem to be increasing in the firm type as well as the worker type. Moreover, if you stare at this picture, it even looks like that the wages seem to be additively separable, just because you can pretty well approximate it as like linear lines that have the same slope. So this would be exactly the representation of the additive separability. It's not exactly that, but it's pretty close. On the right side, you see the sorting patterns. So this tells you when you look at the low type firms, say one or two type 1 or type 2, you see that those firms mostly employ workers that are represented by blue and green lines, which are exactly the lowest type of workers. At the same time, when you look at the very good firms, the productive ones that are types 9 and 10, say, those firms mostly employ workers that are orange or dark black, which are the two types that are the most productive workers. So you see these two patterns coexisting. So wages seem to be monotone, and at the same time we have a lot of sorting going on. So these patterns together might be hard to reconcile within one model, because typically if you have a model with wages that are additively log separable and monotone, it's very hard to generate sorting. In principle, if you think about the McCall model and you put the wage profiles that look like this, and you ask who is going to work where, all workers, because it's log additive separability, all workers should have the same threshold rule, and you should not see any sorting in equilibrium. On the other hand, if you start from a model which features sorting, and you ask what are the wage profiles in this class of models, for example, Scheimer-Smith, then a typical prediction would be that the wages are ham-shaped, which is because it's like the key driver of sorting in this class of models. And this has been pointed out by Lopez del Mello or Eichau Kircher before. So why is it possible? So how is it possible that our model will be able to generate these two patterns together through the same in the same environment? So for us, the key part is going to be played by selection, and it's really the selection on the realization of the match-specific shock that determines what type of meetings are going to turn into matches. And because of this selection, and this selection mechanism that I'll come to later in more detail, is going to drive both things. So the observed, both the fact that the observed wages are going to be monotone, and as well as the fact that that will have sorting in equilibrium. So after we prove these theoretical results, we move to quantitative evaluation of the model. That will add one more feature into the quantitative version, which is the on-the-job search. And in this quantitative version, we'll demonstrate that two things. First of all, that this is a empirically feasible model, so we'll be able to match the patterns we see of the magnitude we see in the data. We'll demonstrate that it features selection the way we talked about in the theoretical section, and that the key mechanism, which is the selection, is hard to detect. So specifically, we'll be running some tests that have been proposed in the literature as tests of selection on our model-generated data to see if those tests will be able to detect selection, and the answer will be no. And then we discuss implications of this mechanism for interpretation of some results in the literature, focusing on the place-based labor market policies. All right, and with that, I'm going to go to the model. So let me just verify that I have 1 hour or
Yes,
1
yes.
hour.
And
Okay.
but also I should say, yeah, panelists, feel free to interrupt anytime with comments and
Okay,
questions. And
perfect.
attendees, at the end of the talk, we're gonna have a Q&A session. My bad.
Okay, perfect. Good. I thought it was 1 hour, but just in case. All right, so let me go to the model. It's going to be a very brief slide on the model because it's very standard. So this is a random search model, and you should be really thinking about Scheimer-Smith style of a sorting model. So on one side of the market, there will be workers who have fixed productivity type X, and on the other side of the market, we'll have firms that have a fixed productivity type Y. In this benchmark model, we have no on-the-job search, so it's only unmatched. Agents that will be able to meet each other. So firms that are vacant will be able to meet unemployed workers at the rate raw that I don't have even on the slide. So when the worker and the firm meet, they draw a match-specific productivity shock Z from some distribution as a Z from some distribution with the CDF S of Z. So this S of Z is the same for all types of meetings. So there is nothing specific to the worker or the firm meeting yet. So once they meet and see a match-specific productivity shock Z, they decide whether to match or not. If they match, then the output flow between a meeting of X type worker and Y type firm with my specific productivity Z is going to be Z times F of XY. So these are not derivative. This is just describing that the production function depends on the types X and Y. And the assumption we are imposing at the moment is that this production is positive. So we're not able to deal with zeros, but otherwise a lot of assumptions are very mild. So, but one assumption is that they produce a positive output. The production function is, and that the production function, we assume that the production function is going to be increasing in both the firm productivity and the worker productivity. So in this meeting or in this match, the wage WXYZ is going to be determined by Nash bargaining with workers' bargaining power gamma. The match lasts until it is separated for exogenous reason at the rate delta. Okay.
So
So
sorry, just to make sure. So the only new thing with compared to Scheimer and Smith is the idiosyncratic productivity shock.
Exactly.
Yeah, and you're somehow, I mean, maybe we should talk about this later, but you're not. I remember that one of the identification assumptions in AKM is that the match-specific productivity shocks are not important, or that's not you.
That is correct. That is correct, and
Okay.
that will be one of the reasons for if you run AKM on the model generated data, you will not get back the deep parameters of the model.
You
might get something reasonable out, but not the deep parameters of the model.
Thank you.
Okay, so if you write down the Bellman equations and manipulate, you get actually to the key 3 equations that are important for what we are going to do next. They are very intuitive, so I'm not going to go through the derivations, but let me just say what those 3 key equations are. So before, I need to introduce 2 important objects. One is workers' reservation wage W bar X, and the firm's reservation profit pi bar Y, which are endogenous objects coming in the determinate equilibrium, and we can prove that both of them are increasing under the assumption that the production function is increasing. So then the first important equation is the structural wage equation, which says that the wage between the worker X firm type Y with the specific productivity Z is given by the worker's reservation wage plus the gamma share, reminder that the gamma is the bargaining power of the worker, plus the gamma share of the output flow generated in this match on top of beyond the reservation wages or reservation values of the worker and the firm. So it's very intuitive. And it's exactly what you would probably expect to get in this class of models. The second key equation is the selection equation, which determines which type of meetings are going to be turned into matches. So by looking at this equation, you will be at the structural wedge equation. You can think about the worker's decision, which is going to be described by the worker will accept the match as long as the wage is above the reservation wage, or the firm will accept the match if the profit is above the reservation profits, which are both equivalent and can be also written in the form that a match is formed as long as the realization of the match-specific shock exceeds some threshold. What is this threshold? This threshold will be denoting Z upper bar. It depends on the worker and the firm type. And just by manipulating this equation, if you think about the match is formed as long as the wage is above the reservation wage, then it means that as long as this object is greater than 0, you get out the reservation threshold, which is that it is the sum of the two reservation values divided by the production. And finally, the third key equation is the stationary measure of matches that will be denoting phi, x, and y. And in the steady state, this is described, so it is described by the Kolmogorov forward equation, which in the steady state says that the outflow out of the matches has to be equal to the inflow into the matches of the given type. In our model, the only outflow is through exogenous separation, so that's the left-hand side, and the inflow is coming through the meetings. So because only unemployed agents search, the share of unemployed workers, I didn't say it, but it's called UX. The share of vacancies is V of Y. So this is the rate at which X and Y meet. And there is also a condition that for the meeting to turn into a match, it has to be the case that the realization is above the threshold. So 1 minus S of Z bar is the probability that the Z shock is good enough. So with these three, with these equations in mind, let me now turn to the main analysis. So really the key part that we want to focus on in this paper is to thinking about the wages. So how the average log wages look like in the different types of meetings, which is exactly the object I have shown in the picture from the Bornholm and Manresa paper. So what is that object? Literally in our model, it is the average log wage in an XY match, which is defined as the average log wage among the matches that have been formed. So you can notice that the integration is over the unobserved match-specific shock Z, conditional on Z being above the matching threshold, and divided by the I have to figure out how to point out without changing the slide. So divided by the mass of such matches. So W star XY is literally the object that Bornholm, and Manresa propose how to estimate in the data. And maybe more familiar version of that object is the one where you impose log additive separability as in AKM style, as in AKM Abel Kramaz Margolis paper, who postulate that the log wage of a worker I at time t is given by the sum of the worker fixed effect, the fixed effect of the firm at which the worker is employed at a time, plus some error term, where the error term has the conditional mean 0. So if wages are truly additively separable, then these two objects coincide, and you would write that the average wage between X and Y type is the sum of the two fixed effects. So we'll be using our model as a laboratory to understand what this object W star XY actually measures. So with that, let me come back to the first key result of the paper, which characterizes the shape of the average log wages. So to be able to get some analytical result, we'll have to assume specific distributions on the Z shock. And the two distribution on which for which we have closed form solutions are that when Z is either distributed either Pareto or exponential. So what is my goal here? So now I want to really characterize what is the average log wage between the worker type X and the firm type Y. So what do? I take the structural wage equation and calculate and literally calculate this integral and manipulate. So you could see that because here I'm integrating over the realization of Z's, I need to know something about the distribution of Z. So the first result is that if Z is distributed Pareto,
can I ask,
yes, yes.
Are you, I take it you're not particularly interested in the parameters of these exponent or Pareto distributions, right?
Well, when we come to quantitative evaluation, we'll need to link it to something in the data.
Okay, yeah,
And
because
in
I
that
was just
case,
thinking, if I had the model also had selection on the exits, you know, that's gonna make everything sort to higher Z's. You know, your equation for the steady state, we're gonna sort you to skewed higher Z's, so that might make you think that more general model would have I can't do it, but a higher or lower parameters.
right. So with the
But I don't know if that matters for anything you're gonna do.
I don't think so, because like that one for us is going to be what it has to be if you want to explain the data, but specifically like the specific value is not that important, only to the extent to think about, do we need a lot of variance in the Z shock or a little variance in the Z shock to be consistent with the data?
Yeah, you know, my
Only
conjecture is it would have, in a model with selection on both the ins and outs, it would have a calibrate to a lower variance, but.
Right. So if we have, so in the quantitative version, we'll have on-the-job search in it, and then we'll have to calibrate it to and it is true that we'll need lower variance of Z in that class of, in that version of the model than without on-the-job search. That is true. Okay, so the first result. So when the Z is distributed Pareto with the shape parameter theta greater than 1 and small enough scale parameter so that we always have interior solutions, then this is the expression for the average log wage. So when you look at this formula, what you notice is that this depends on 4 objects. One is the reservation wage of the worker. One is the reservation profit of the firm. And just by staring at this formula, you can see that both of them enter in a way that makes the average log wage increasing in W bar X and in pi bar Y. And because those are increasing in productivity, that gives us the first important result about the monotonicity of wages. The other two parameters that enter here is the bargaining power of worker gamma and the Pareto tail theta. Q is the dummy variable through which we integrate. So interestingly, one thing that comes out of this version of the model is that the production function itself does not show up in the expression for the average log wage. True, production function determines the W bar X and pi bar Y because these are endogenous objects, so everything is determined, everything enters there. But on top of beyond the reservation values, the production function doesn't show up. Why do I?
I apologize for. Is this that result Manowski? I think that you cannot identify sorting only by looking at wages is something.
So that will be related to that, because exactly one consequence of this expression is that just by looking at the average wages in these meetings, you cannot tell anything about the complementarity in the production function. So in this world, you can learn a lot about the complementarity in the production function by looking at the sorting patterns, but not at the average wages themselves. At the same time, this is a knife edge case because it's only true for the Pareto case. If we go to exponential distribution, then this is the average log wage for the Pareto for the exponential distribution. Z, but now you see that the production function shows up. So it is an IFS sketch, but I think it's a very valuable to think about where is the place that you should be looking for evidence of complementarity in the production function, and just this tells you that probably wages is not the place. So the first result, just to sum up, in these two cases for which we can derive analytical results, the average log wages are increasing in X as well as in Y. So that gives us the patterns on the first figure for wages. All right. So what does it imply for some? So now we characterize the wages. So we want to think about what does it imply for some results that have been documented in the literature. So here we are coming back to the paper by Carr, Cardozo, Heinlein, and Klein, 2018, who were asking whether it is the case that a conventionally estimated firm-specific pay premia, meaning the fixed effects for the firm in an AKM type regression, predict the wage changes that are associated with exogenously induced job accession or separations. So what I have in mind is to think about whether when you estimate a fixed effect for the firm, whether you can think about it as a wage gain that the worker would gain if you move that worker from one firm to another one. So because so here I want to think about the worker I that has of some fixed type xi and a firm j of a type for type yj, and in this case in this environment, a conventionally estimated worker and firm specific pay premia would be the average log wage over the realized xy pairs, meaning that you would take the wages that you observe in the matches that have been realized, and you calculate what are these what the average wage in such matches are. Would it be the case that this average log wage would predict how much a worker would gain from an exogenously induced job change? Well, not in this model, because you have to think about two other things in this model. One is that the worker I and firm J will have to meet first, and then even if they meet, they have to decide whether they want to create a match or not. And so in that case, if you want to think about what's the value of that object, you would need to think about the average wage not only in meetings that have resulted in matches, but in all meetings. So this is just to say that this endogenous selection has some implications for how you want to interpret a conveniently estimated fixed effects in the empirical literature. So since we have said that the really important part in driving this monotonicity of wages was selection, an interesting question is there somewhere else where we can observe this selection? And in this model, selection is not only shaping the wages, but is also shaping the sorting patterns. So let's go back again to the same assumptions on the Z distribution that we have made. And we prove the following results. So if Z is distributed according to Pareto with shape parameter theta, and now we have to impose one additional assumption on the production function, which is that that f is weakly log supramodular. Then in that case, there is sorting in equilibrium, a very strong notion of sorting, specifically that phi has the monotone likelihood ratio ordering. Actually, I should have mentioned when I was talking about the wages that we did not impose any additional assumption on the production function. The only assumption to get the result for monotonicity of wages was that production function is increasing in the two arguments, and that it's positive. We didn't need anything about cross partial for that result. So it's a very strong outcome.
But just to make sure, this says that you can have negative assortative matching and increasing wages. Is this the model? Can this happen? Because you said, look, wages can be increasing. I don't.
Yeah, so if you say in the so you can have yeah, that's correct. So you can have so the wages will be so the result for the wages is that as long as production function is increasing, you will get a monotone wages out. Now, if you bundle it with the case that you will have log submodular production function, which might lead to negative assortative matching, then you get the two outcomes out.
And the intuition is, look, there's negative assortative matching, but really we draw such a good Z that the output is so high that I'm gonna get.
That's exactly the case for the wages. That's exactly right. Yeah. So both of those things that are so let me just finish this slide. I'll go back to talk a little bit more about the selection, which is so for the exponential distribution, we need a slightly stronger restriction of F, but in both of these cases, we get that there is a positive assortative sorting in equilibrium. So let me now talk. I don't know if I have it on the slides, but let me now exactly talk a little bit about how the selection is operating in this model. So really, the key selection equation is the match specific shock has to be above some threshold for a meeting to turn into a match. So if you think about this case where we have where the production function is log supermodular, then if you have two types, worker and the firm, who are similar to each other, so they are going to be productive together just through the production function F, they do not need that much of a kick from the specific production shock. So they are going to have an acceptance threshold that is going to be relatively low. So that is going to drive the sorting just because a lot of realization of the Z shocks are going to be above the threshold, and then such a meeting is going to turn into a match very frequently. If you think about the types that are different, so a low worker and a high firm type, then those guys are not very productive together through F. So they are going to need to rely on a realization of the Z shock quite a bit. So for them, the threshold is going to be high. So only very few realization of the shocks are going to be above the threshold, which means that these two guys are going to be observed matched together very, very infrequently. So these two pieces together is driving the sorting. But at the same time, this is also driving the monotonicity of wages, because if you see low and high type together, it was because they had a really good realization of the Z shock. But if they had a really good realization of the Z shock, it means that they also have a high wage associated with the match. So the selection just operates that for many meetings of the low and high type, we disregard a lot of realizations of the Z that are not good enough. So this is, and you only keep the realization of the Z's that are good enough, and those are also associated with the high wage. So this is really the selection driving the monotone wage pattern that we observe in the data. So now this is I think an interesting important mechanism and pretty simple. So I think an interesting question that we have to now attack is, first of all, is this empirically reasonable? So is this strong enough? And second, can we test for it? So this is the two things that I'm heading next. So first, for thinking about the quantitative relevance of this mechanism, we are going to put some numbers into the model to see how well this model does. To do so, we are going to extend the model to allow for on-the-job search. Why? First of all, it's very realistic, and second of all, it will allow us to generate more within worker wage dispersion through the lens of the argument of Horstnay-Cruz and Violante. So we did not have the on-the-job search in the benchmark model just because we are not able to prove all these analytical results when there is on-the-job search. Nevertheless, through the numerical solution of well-calibrated model, will show you that all these features that I have been talking about are preserved in this environment. So both unemployed and employed workers will search, but at a different rate. And the wage setting is going to be such that we say that the worker gets a share of gamma of the joint surplus. So the advantage of that is that if we take the limit as the surge intensity of employed workers goes to 0, we'll back to the benchmark model. So there are going to be some parameters that are standard and some parameters that are not standard that I want to explain how we got. So I know that I didn't give you all the full details of the model, but the parameters that we need to take stance on are the discount rate. So this is going to be 5% annually. So for us, one unit is time unit is going to be 1 year, but the model is written in continuous time. Delta is the separation rate. We say to 0.25, which means that on average an employment lasts for 4 years. Gamma will be 0.5, so the worker and the firm have the same bargaining power. Rho 0 is the meeting rate, is the meeting intensity of unemployed workers. It is a normalization and it's normalized to 1. And then relative to that, we say that the workers surge at the intensity that is 0.2 of the surge intensity of the unemployed workers. This number is disciplined by the frequency of the job-to-job moves that we observe in the data. So now the other parameters that are somewhat new or specific to our environment. So one is the distribution of the z-shocks. So we'll be doing all this calibration for the case where z is distributed Pareto with the shape parameter theta. So that's one parameter we need to calibrate. We'll assume that there are 10 types of workers and 10 types of firms that are distributed equally in the whole population. And then the production function is CS with the elasticity of substitution high. That's the second parameter will be targeting, and the third, and then finally we say we need to specify how different the different worker types are, and we say that each worker type is delta W times more productive than the previous one, and similarly for the firm types. So this specification leaves us with 4 parameters. So theta, high, and the heterogeneity on the worker and firm side that we want to put reasonable numbers on. So what are we going to target? So we are going to target a wage decomposition from 2 credible estimates of the decomposition, if you will. So if you think back to the AKM specification that says that the log wage is the sum of the worker and the firm fixed effects, then this leads to a very nice decomposition of the variance of the log wages, which is the variance of the one fixed effect plus the variance of the other fixed effects plus the covariance and plus the error term. So we take estimates from 2 papers. One is from Bonhomme, Lamadon, and Manresa, their dynamic version of the model. And the other one is the log wage decomposition from Klein, Saggio, and Solsten 2020. Why these 2? Well, AKM has a lot of troubles with AKM has a bias if you try to estimate the variance decomposition, and these are the 2 papers or 2 credible papers that would say that they know how to solve the bias in the variances. Different ways, but both of them are dealing with the bias. So these are also quite interesting because they have a very different variance decomposition. So it's actually for us it's instructive to be able to say that our model can match both of those, which was not guaranteed upfront. So besides,
they're using different countries, probably, right?
Yeah, there are different countries, so that's one problem, and different methodologies, so that's the other one.
Yeah, okay.
Yeah, so which one is more important? I think both of them actually play a role. And what is interesting about these decompositions is that BLM have probably one of the lowest, if not the lowest, share of the firm fixed effects variance in the total decomposition. So one other notable difference is the correlation between the or the extent of sorting between the types. That is very different, and also the role of the error term. So we do two separate calibrations. In one calibration, we target the BLM numbers, and in the other calibration, we target the KSS numbers. We are able to hit both, so that's very nice. The parameters that come out of those calibrations are very different, of course. So let me comment on some of them. So theta, that's the Pareto tail. What is informative about that is really the variance of the error term. So in many of the studies, error term is viewed as a measurement error. In the cases, for example, it's not even reported. So it's something that is very uninteresting. For us, it's actually a very important moment that we want to hit, because it's really because it's exactly informative about how much variance of the match specific shock there is. So because there is much higher variance in the BLM, it also means that we'll have a much higher variance of the Z shock in the BLM calibration than in the KSS calibration. Variance is 1 over theta. Psi, that's the production function. That's the elasticity of substitution in the production function. In the BLM calibration, it's below 1. So this is the log supermodular case. In the KSS calibration, it's 4. So this is actually above that. So 1 is Cobb-Douglas, for a reminder. Below 1 is log supermodular. Above 1 will be log submodular. So you can see that, and you will see, I will show you that there is still positive sorting in equilibrium, even with the production function that is not log supermodular. And then let me now get back to these deltas that describe how different workers and the firms are. So delta W is 5% or 7% in the two calibration, which says that every next type is 5% or 7% more productive than the previous worker type. And remember, we have 10 types, so it actually, if you compare the last and the first one, it cumulates to quite some difference. But we have much bigger heterogeneity among the firm types. So in the BLM calibration, every firm type is 26 times more productive than the previous, 27% more productive than the previous one. And in the KSS, even 58% more productive than the previous one. So this really is so we really are getting a huge heterogeneity for the firm types, which is still the case despite the fact, and I think this is quite interesting, despite the fact that when you look at the variance decomposition, the variance of the firm fixed effect is so much smaller than the variance of the worker fixed effect. And you would be tempted to conclude that there is much more variance among the worker types than the firm types, but actually it's exactly the opposite, that this model needs to be able to match these numbers.
Does the number of types, I guess you want to do 10 to be consistent with the empirical papers, but does the number of types matter? Is this?
No, it doesn't. But then what would be interesting to say, how much more productive is the best type relative to first type? And then if I split it to 10 beans, then it will be 5%. But if I split it to 3 beans, it will be 50 divided by 3%. So yeah, so the relevant comparison will be the best and the worst rather than every other type. Yeah, but the number of types is not so important. It might be actually 10 types might be even too many in a sense.
There's this literature that, Kudliak and a bunch of other people, how many workers.
There are just 3. Yeah, I mean
your paper as well. Yeah, maybe,
I mean, in our paper as well, like when we had the unemployment paper, we allowed for a lot of types, but then at the end, I think 95% of the unemployment spell were explained by 3 types. So yeah, I think there is something to it. And also, if you go back to this figure I put forward, there is really the firm types. There are 10 firm types, but between 3 and 8, actually nothing is happening. It's like flat line. So I think it even suggested that if you were to bunch the middle type firms into one, you would have exactly the same explanatory power. So there is a sense in which that might be too many.
Very good.
Okay, so these are the results. So first, let me just show you what comes out of this model with on-the-job search, because I did not show you any analytical results for it because we don't have them. But this figure shows you that it's the key patterns are preserved. So the average log wages are increasing in the worker type and the firm type, and at the same time, when you look at it, they really look like they're additively separable. Like these are really like flat line and with a parallel shift. So if you were to think that the AKM specification without any cross term is a good description of average wages that are observed in the in economy, then this model will say, yeah, sure, it's actually a very good approximation of it. And then on the right hand side, you see sorting, and yeah, you see that there is still sorting. There is high type workers in high type firms and low type workers in low type firms. The same is true for the KSS calibration. Again, actually here you can quite see that the middle types are basically just one, because when you look at the firm types 5, 6, 7, 8, and 9, they look very, very similar to each other. So probably there is not much going on here, and you can just bunch them together, and the wages are again monotone. Okay. So in last thing that I want to talk about is testing for selection. So the whole theme of this paper is to say that you can explain these two patterns together, even though they look like you would not be able to explain them within one model with only productivity shocks in it. If you have selection driving the wages that are observed in the data. So then an interesting question comes, well, can we actually test for this selection? And we are not the first one to be thinking about selection. And actually the whole empirical literature that was dealing with AKM style regression has been thinking about selection already. Because as one of the questions came up at the beginning, is that in to be able to run AKM regression, you actually need exogenous mobility assumption in it. So which means that the error in the wedge equation is mean zero conditional on any employer type J. So you cannot really test for selection. Sorry, you cannot really test for exogeneity assumption in the administrative data, but the literature has thought about some auxiliary tests that might be able to speak to this assumption. So the best known test is the one suggested by Card, Heinen, and Klein in the 2013 paper that is now called as the event study. So what have these people been thinking about? So they have been thinking whether exogeneity assumption exogenous mobility assumption is violated due to workers selecting jobs where they are going to move to based on the realized wages in the new job. So really like something like the on-the-job search mechanism that they were trying to exclude or test whether it's present in the data or not. So we'll follow the test and implement it on the model generated data to see what it comes from. So briefly, what is this test looking at, or this event study? What is that looking at? They are looking at workers making different moves and looking at the wage changes associated with those moves. So they are going to sort firms into 4 bins based on how good a firm is. So the firm in the first quartile is going to be firms in the first quartile are going to be the worst firms, and in the fourth quartile are going to be the best firms. And they are going to look at workers who move between firms in these different quartiles. And what they are trying to see, if it is the case that every time you see a firm moving to a different firm, that move is associated with a wage increase. So instead, what they find is that there are a lot of moves that are associated with wage increase and a lot of that are associated with the wage decrease. And I think it's nicely depicted in this figure. So let me say what this figure is. So this is from the Cardoso, Heinen, and Klein paper, where they are looking at the moves between different pairs of the quartiles of the firms. So for example, this dot over here is looking at the workers who move from quartile 1 to quartile 2 and look at what is the wage change associated with such move. That one is depicted because it's going upward from the worst to better firms. That wage increase is depicted on the horizontal axis. So that would be 10%. And then on the y-axis is the wage gain coming from the opposite move. So if you were in the good firms, quarter 2, and you move to a quarter 1, what is your wage gain? So this is typically negative, and on average, it's the workers who made such a move are losing 10%. So this is a minus 45-degree line, which is saying that if we see this move being exactly offsetting in terms of wages, all these dots would be aligned along this dashed line. So so you can see that these dashed lines are so that the data are actually very close to the dashed line, meaning that first of all, that if you go to a if it is an upward move to better type of firms, there is the wage increase is positive. If you do the opposite, is on average negative, the wage gain, and at the same time they are almost exactly offsetting each other, or there are in the magnitude that they seem to be very close to each other. So this has been interpreted as saying a few things. One is that it doesn't look like that workers are moving towards better jobs as in on the job search world, because in that case we would not see a lot of wage drops. And second, it also has been interpreted as a justification for log additive separation, because that's exactly what you would observe, or what you would expect if every change between the two firms types is just associated with the change in the firm fixed effect. Then it would be positive or negative, but of the same magnitude.
Cut 10 minutes, just a reminder.
Sorry, what? That's only 5 minutes. Okay, so
10 minutes, yeah.
Yeah, fine. So we run the same test in our data, and this is what we find. So this is from the data with on the job search in it. So if you just to make sure that we are not excluding any job-to-job moves. So there are two figures again, because one corresponds to the BLM calibration, one corresponds to the KSS calibration. But the point of both of those is that these dots are very close to be aligned along the dashed line. So it's very similar to what we have observed in the real data. So if people have concluded based on looking at this picture that there is no that assumption of exogenous mobility is reasonable and it does not seem to be violated, you look at this picture and you would arrive to the same conclusion. Even though, so you would, based on this test, you would conclude that there is no selection going on in our model, despite the fact that I have just spent past 50 minutes telling you that there is selection in the model. So these tests are not really informative about the type of selection that works in our model.
It's a bit counterintuitive, right? You would expect I mean, the selection, having much productivity, that the positive moves would be a bit, I don't know, the positive moves you would expect to dominate, right? I mean, at the end of the day,
so there are so this is actually quite interesting. We spent quite a bit of time on thinking about why is it the case. So I think so now we think that really this test has nothing to do with exogenous mobility, and really it's more of a test of a stationarity of an environment. So think about a steady state in any model, basically. So the distribution of wages today and next year have to be exactly the same. So instead of looking at the firm split into 4 quartiles, let's think about the firm split into 2 types, below median and above median. So if you are in a stationary world, then if you see and you see workers moving up between the firms, then the wage gains of workers who move from below median to up to median has to be exactly the same as the wage loss of workers who move from above median to below median because we are in a steady state. Now, why? And then if you are in the world without on-the-job search, those workers who move between the below median firms and above the median firms will have zero wage gains. Now, why would you not exactly see symmetry in this class, in this figure, is for maybe two reasons. One is that we are not looking at two types of firms, but four. So there is no reason for any pair has to be bilaterally the same. So it has to be this. It has to be balanced on average, but not between any two pairs of firms. And second, we have on-the-job search. So even if you move between firms within the same category, there is going to be wage gain associated with that. Still, it turns out that these wage gains associated with this move within category and are not strong enough to overturn this overall picture that the wage gains and losses have to be on average balanced. So, I mean, and then one other thing why it might be not exactly the case in the real data is because there is some life cycle going on.
But
in a
stationary, sorry, but there's nothing in the figure that says the frequencies of these ups and downs are the same, right?
Correct, and it's not. And it's not. So that's actually one thing that our model will not get, right? So the frequency in the data, the frequency of up move is much higher than the frequency of down move. And this model will actually predict something that is much closer to each other than what we see in the data. So that's one thing that we don't get. But yes, frequency is not here. Okay. So I have 3 minutes. So let me just maybe mention one last thing, and then I'll conclude, which is just to think about, just to going back about interpretation of the estimates you get from empirical literature, and whether you can think about some of these estimates as being the gains that a worker can gain if you move a worker from one type of firm to another. So what makes us thinking about this is really the popularity of place-based policies to fight inequality, where there are really like real world examples where a government has decided to build a high-type firm in an environment that is not populated by high-type workers, just to think that will promote the low-type workers and give them a chance to get higher wages. So how do we think about this type of experiment in our model? Is that the government, by placing a company, good company in a poor area, it's going to induce more meetings between low type workers and high type firms. So what would our model predict would happen to wages and to sorting in general in this environment? So it's because this is a search model, and it's also there is an endogenous decision to turn meeting into a matches. We want to think about this type of policy as inducing more meetings. But then, conditional on the meeting, we still let the agents decide whether they want to match or not. So to make this very stark, we are going to compare what's the value of meeting of the two types of agent versus what is the value of matching between the two types of agent. And the value of matching is the Bellman equations that I didn't show you, but those are that you would have write down if you were to solve the model. While in contrast to that, the average or the surplus in meetings also takes into account all the zero surpluses for meetings that do not turn into matches. And this is what you get. So on the left-hand side, you see the average surplus in matches. Again, firms on the horizontal axis, and each line corresponds to one worker type. And the average surplus in meetings is on the right-hand side. So what is interesting about this is that the average surplus in matches, it has the monotonicity as we see in the wages. This is not surprising. I mean, this is exactly what you would expect. But interestingly, the average surplus in meetings, it's not monotone. It's not necessarily monotone. And and moreover, if you look at the lowest types, these are the violet guys in this picture. The lowest types have a much higher value from meeting a low type firm than a high type firm. And this is exactly because if this worker meets a low type firm, then very often it is going to result in the match. While if this worker meets a high type firm, very often it is not going to result in the match, and the worker will get 0. So this is just to say that by looking at wages and the monotonicity of wages and concluding that it would be a great policy to induce more meetings between the low type workers and high type firms is not a good idea in this model. And I'm out of time, so I'll conclude. So what have we done? So we studied a model with two-sided heterogeneity and match-specific shock. The key result is that this model delivers assortative matching and increasing wages. And from the pictures, they were actually near separable. So the key mechanism is that there is systematic but very hard to detect selection. And what we also like about this model is that really it's very sparsely parameterized, and it offers a novel interpretation of these empirical findings. So it's a complementary explanation to the one that exists in the literature of rationalizing these two figures of wages and sorting, which works through amenities and no selection. Thank you very much.
Thank you. Great stuff. Folks, the floor is open to questions and comments. And I'm also gonna promote our attendees into panelists if they wanna ask questions. So please, let's ask.
Let me ask a question. Given that the two examples that Katka showed were from Sweden and Italy, and both are countries where wages are kind of regulated in the sense that there is collective bargaining, there are minima, so it's not that wages are perfectly flexible, no? So I don't know whether in another country where there is no such rigidity, perhaps it will be easier to detect selection.
No, so the investigation was done on the model generated data, and I don't think it was contingent on the way the model has been calibrated. So I don't believe that if the model has been calibrated to a different country with more flexible wages, that it would change the conclusion that the type of tests used to detect selection is not going to be working well in this model.
So ideally, what we would like to have is like to have job applications, no, and have actually those matches that didn't realize. If you could get like data on job applications.
Yeah, well, yeah. So one place where you can differentiate between different explanations, if one where there is selection, where there isn't, it would be exactly what kind of matches are not turned. Sorry, meetings not turned into matches. But I don't think that this can be reasonably done. I mean, I of course understand that there are survey data that ask workers on type of jobs that they have rejected, or they have offers but they didn't take them. But then you also need to see the other side, which is how many applications were applied to the firms and the firm didn't take them. So it's going to be I'm not very hopeful that this will be the way we would be able to test for the mechanism.
Katka, I had two questions. One is related to your very last point. So how do you distinguish between selection and this amenity story, which is that low type workers get a disutility from being at high type firms, and so the way has to compensate? So that is one. And the second is how much are the results dependent on this assumption of Nash bargained wage and this match specific productivity being constant during the match?
So for the first question, can we distinguish our story from the amenity story using administrative data? No way. These two models are observationally equivalent, and we don't observe amenities, we don't observe selection. So both notions are correct in generating the answers. So I think one thing that I would say for the amenities to be working is that you really need kind of counterfactually design amenity stories. So specifically, you need low-type workers hating high-type firms because they have high wages, but they are never working there. So really, the amenity must be such that the low-type workers really don't like high-type firms. So I think it's like a sanity check whether this is a something that passes the smell test, but it's not something that is well in our model we have no amenities and everything is operating through wages. So I think that just like a matter of taste at this moment, just because there is nothing, it's observationally equivalent. That's the reality. And for the second question, you were asking how much this relies on the Nash bargaining. Actually, if you look at the wage equation, it's really the wage equation is the only thing that is needed for the whole analysis that we have done. And the wage equation says that the wage a worker gets is the reservation wage plus some share of the surplus. I think if you put a different wage protocol in it, you'll get similarly looking wage equation, and that's all you need. It's really like we didn't rely on anything else, any details of the model. It just was really like very intuitive wage equation. Is the reservation wage plus something from the surplus that is operational. Yeah, I mean, we derive everything for a fixed type. So the worker types are not changing, firm types are not changing. And for the duration of the match specific shock is not changing. But then, yeah, you can think about a extension where something changes. For example, you can get two shocks to match specific shock, and maybe sometimes you separate if it goes below the separation threshold, or maybe it has changed. So in our model, it would all go into the error term. So in that case, we are kind of loading, we would be loading much more on the error term than in this version of the model. But we still think that the key mechanism that you have only, I mean, really the key mechanism is that the set of wages you observe in the real data is just a subset of all potential wages, and it's not a random subset. It's a subset that has been selected in a specific way. And I think that message stays even if we have if we introduce the shocks.
Thanks.
Hi, Katka. I had two questions. First one is actually fairly simple. I was wondering if in your model you have, so basically wages and hours are the same, right?
Correct.
And so that it doesn't have any effect on your
no, in this model, yeah, there is
variance.
no, and plus the separation rate is exogenous, so there is really no distinction between wages and income. It's exactly the same.
I see. And the second question is more about so in your calibration for KSS, you have higher elasticity as well as your shape parameter is also higher compared to
Yes.
the Swedish data. Do you think is this because of institutional setting or why, how should we think about this?
I mean, yeah, it definitely captures some differences in the labor market. These are two different labor markets. For Italy, the KSS use just one region in Italy. Sweden and BLM use the Swedish data, so it's like a different economy. So it's natural to think that there are parameters that are different. At the same time, these are also the decomposition has been done using two different methodologies. So And I can attest to that the methodologies make a difference too, because I was actually in the last few weeks I was playing with with the data generated from our model and running BLM on it and KSS on it, and it's the same data and they give different answers. So for sure, part of that is the different methodology. But at the same time, I do believe that Italy, one region in Italy and country of Sweden are different labor markets, and they should be characterized by different underlying deep parameters.
I had one question about or actually two questions about the results regarding the submodularity in wages. So the first is about the data. So I don't know the literature that well. So my understanding is that at least Bonham and co-authors find some evidence on that with Swedish data. But
Yes.
how general that result is, like for example, does KSS, do they find it the Italian data?
Yeah, no, I like the question. Actually, at the beginning, we were really pushing forward the fact that the wages in BLM are sub-modular. So if you think about who gains the most from moving from low term to high term, it's the low time workers, not the high time workers. And this model with the Pareto case and actually delivers sub-modular log wages. And that was a proof that took us actually a very, very long time, and now we don't even stress it. But so in the model delivers some modularity, but that's a finding that is not that robust in the literature. So we know of BLM that deliver that is submodular, but then when you look at some papers by Klein, now here's so many that now I'm not exactly sure which one I'm talking about, but there is one paper where they estimate the types and they plot the residuals between different workers and the firm types. And when you look at the shape of these residuals, they actually suggest that there is super modularity in the average wages. So then we have decided that it's probably not that robust. And plus, when you look at the shapes even generated from our model, it is not exactly separable, but it is so close to being separable that maybe focusing on whether it's submodular or not is less important than thinking that really the cross term is absence of the cross term in the wedge equation is not a bad idea if you want to describe how the wedges among the match workers look like.
Yeah, because I was thinking, for example, the case of Sweden, I could maybe the finding about submodularity has to do with the compressed wage setting. So there are new studies that show that the inequality is so low in Nordic countries because the wages are really suppressed from the or compressed from the top. So maybe that could, I don't know if that would create that result, and maybe that disappears in other types of wage setting.
It might, and through the lens of our model, it doesn't have to, because the case, our model has none of those features of compressed wages,
right.
Yet it delivers, even has to deliver. In the case without on-the-job search, it actually has to deliver submodular wages. We have a proof of that. So it could, but it doesn't have to. Yeah. So, but yeah, it's
okay.
an interesting question. Yeah. Nobody else ever asked about it.
Thank you.
Any final thoughts? I have one, so I'm going to just take everybody's time. I think no, it's a comment. Not, I mean, the presentation was excellent. The paper is somehow just I have a bitter taste with the message. You know, the ACAM is such a great organizational principle, and you know that symmetry of movement is so powerful. And the power in your argument is to say, look, I wrote down a very natural framework, and it delivers the same things. And I just feel a bit, I don't know, a bit sad.
So let me say that the ACAM moments are very powerful in identifying the underlying structure of the model. So all of those, the variance decomposition that we looked at, each of them is speaking very strongly to the parameters of our model. So it's really a good thing that you want to look. It's really a good set of moments you want to look at to calibrate your model. The thing we take issue with is pushing the interpretation beyond looking at it through the lens of structural model and say all the things like, oh, the variance of worker fixed effect is higher. That means that it's all about the workers and nothing about the firms in the wage setting mechanism. Or looking that all the correlation between the workers and the firm has increased. That means that there is much better sorting, and it must have been coming through, I don't know, underlying structure of the heterogeneity. It could have been because the search technology has changed. So I think that's the issue we're taking, we are not happy with. But the fact that you want to run AKM and get these numbers out, I think we agree that you want to do it. These are very informative moments.
Very good. Very good.
Yeah.
Awesome. Thank you. Excellent. And folks,
Perfect.
thanks again for your time and comments. That was really good. Stay tuned for our next seminars, and yeah, hope to see you soon in person.
Thank you very much for the invite and everyone for coming and for the comments. Thank you.